Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I am a mentor and your friend for the subject chemistry, and I will be dealing with the organic chemistry. My dear students, today I am going to start with biomolecules. In this chapter, we will learn about the different and the important biomolecules, means the molecules of biological system which are involved in different types of biochemical reactions. Under this category, we will be first dealing with carbohydrates. We will be first dealing with carbohydrates. Carbohydrates, they can be classified, they can be defined as polyhydroxy derivatives of aldehydes or ketone. So carbohydrates, they are the compounds having multiple OH group, and along with it they have an aldehydic group or a ketonic group. So they are polyhydroxy, means multiple OH group, and they have a aldehydic group or a ketonic group. These substances yield polyhydroxy aldehydes or ketones on hydrolysis. So in both ways we can define carbohydrates as they are the compounds having polyhydroxy, they are the compounds which are polyhydroxy derivatives of aldehydes or ketones, or on acidic hydrolysis, if the compound is delivering, if it is giving polyhydroxyaldehyde or ketones, then also they are carbohydrates. Carbohydrates, they are also known as saccharides, which are sweet in taste. So all the saccharides or the compounds which are sweet in taste, having some sort of sweetening index, they are known as what? Sugars. Known as what? Sugars. Okay. Previously, it was a belief that carbohydrates, they are known as hydrates of carbon. I mean, if I go that this definition is the new definition. This one is the new definition. Okay. Before it, it was believed that the compounds having a formula CxH2O whole Y, okay, CxH2O whole Y. So previously it was a belief that carbohydrates, they are hydrates of carbon. They are hydrates of carbon, okay. These compounds are naturally occurring compounds and having a general formula of CxH2O whole Y, okay. So previously, the definition of carbohydrates, it includes that only. The carbohydrates are hydrates of carbon having a general formula of CxH2 whole Y, which are constantly produced in nature and participate in different and important biochemical reactions. Okay. Now, what are biomolecules? Biomolecules, they are the chemical substances which are required by biological system for their sustainment, for their survival. So all these biomolecules, whether they are proteins, whether they are amino acids, whether they are vitamins, whether they are, you know, uh, lipids, fatty acids, and glycerol, so all are biomolecules. So all chemical substances which are required by one or the other biochemical pathway is a biomolecule. Okay. Examples are glucose, fructose, cellulose, starch. All are carbohydrates. They all are carbohydrates. Okay. Sucrose, also known as cane sugar, general formula. The formula is C12H22O11. Okay. Maltose, which is a malt sugar, it is also having formula C12H22O11. Okay. Now, exceptions. There are some compounds which are having the molecular formula CxH2O whole Y. Means as we know that in water, the ratio of hydrogen is to oxygen is to 2 is to 1. So in the same way, we actually learn about the carbohydrates, that these carbohydrates they are having the formula 2 is to 1, which actually resembles water. Okay. So there are many compounds which are having the molecular formula CH2 whole Y, but they are not carbohydrates. Like formaldehyde, you can see, acetic acid, lactic acid. So the making of formula of all these compounds this is actually resembling this, but they are not carbohydrates. Okay, they are not carbohydrates. There are many compounds which show chemical behavior of carbohydrates, but do not confirm the general formula. They show the chemical behavior of carbohydrates, but they do not confirm the general formula. Like 2-deoxyribose, the formula is entirely different. C5H10O4. Okay, Ramanose C6H12O5. So both of the ways, the compounds having the formula, but they are not carbohydrates. Compounds resembling the chemical behavior, but they are not having that formula. Okay. Now, classification of carbohydrates. Carbohydrates are classified as, when we classify carbohydrates, substances which are sugars, which includes monosaccharides and oligosaccharides. Substances which are non-sugars, which are not sugars. Okay, it includes polysaccharides. Sugars are sweet in taste, they are crystalline, they are soluble in water. These compounds, which are polysaccharides, they are not having any taste. They are tasteless, they are amorphous solid, and they are insoluble in water. The polysaccharides they undergo acidic hydrolysis and they form many sweet monosaccharides. Okay, many sweet monosaccharides. So many sweet monosaccharides they can resemble each other or they cannot resemble each other. So these polysaccharides are also further classified as homopolysaccharides and heteropolysaccharides. Okay. So these polysaccharides they are further classified as homopolysaccharides and heteropolysaccharides. Okay. Monosaccharides they are further classified as whether they are aldose sugar or whether they are ketose sugar, whether they are having aldehydic group or whether they are having ketonic group. Oligosaccharides contain 2 to 10 saccharide units. Okay, 2 to 10 saccharide units. If a compound which is or which can be hydrolyzed into 2 saccharide units, then it is disaccharide, like sucrose, maltose, lactose. If it can deliver or give 3 saccharide units, then it is a trisaccharide. If it can give 4, then tetrasaccharide, and so on and so on. Understood? Okay. So monosaccharides they are simple sugars and they cannot be further hydrolyzed. When you cannot break it. The general formula is CnH2n whole n. CnH2n Examples glucose, fructose. Okay. Now I would like to end. Yeah. Now listen to me very carefully. In the previous slide, you got to know that monosaccharides they are having this formula CnH2n ON, where N can vary between 3 to 8. Okay, there are almost around 20 more monosaccharides which occur in nature. Okay, the simplest monosaccharide is triose. Simplest monosaccharide is triose sugar. Monosaccharide is triose sugar. Now, the name triose basically giving the reflection. Okay, this compound is having three carbons. Okay, that is why it is known as what? A triose sugar. It is having three carbon. When this compound is a single entity, it is a single compound which is having three carbon. So it is known as what? Triose sugar. Okay. Now, depending upon the functional group these compounds are having, they are further divided into the aldotriose or the ketotriose. Aldotriose and ketotriose. Okay. So on the basis of the on the basis of a compound having the aldehyde group or the ketonic group, they are basically aldotriose or ketotriose. Now, a three carbon containing compound, a sugar, which is a aldotriose, is glyceraldehyde. And same, the three carbon containing ketose sugar is dihydroxyacetone. Now, a very important thing. Aldehyde and ketones, they are functional isomers. Aldehyde and ketones, they are functional isomers. That is why interconversion of glyceraldehyde into dihydroxyacetone and dihydroxyacetone into glyceraldehyde can be possible because as they are functional isomers. Okay, so this is aldotriose, which is a glyceraldehyde, okay, and ketotriose, which is example is dihydroxyacetone. Okay, if you will draw the formula, then this is glyceraldehyde, which is a aldotriose. As you know, the ketonic compound, this is the carbonyl group, okay, which always comes in the middle of the chain. This is dihydroxyacetone. Okay, so it is a ketotriose, mean a triose sugar, a compound having three carbon atoms, and is having a ketonic moiety, ketonic group. And this is aldehyde group. Got it? So this is glyceraldehyde and dihydroxyacetone. Now, when we talk about that carbohydrates, they are optically active. Okay, So for a compound to be optically active, they should have asymmetric carbon atoms. I mean, general concept is if the compound contains asymmetric carbon atoms and if they are optically active, they show optical isomerism. But except these two compounds, dihydroxyacetone and glyceraldehyde, okay, when except these two compounds, okay, when for example, if you want to find out the number of asymmetric carbon atoms in glyceraldehyde, for example, if you want to find out number of asymmetric carbon atoms in glyceraldehyde, then you will be able to find out the number of carbon atoms, asymmetric carbon atoms. Asymmetric carbon atom simply means, I will write the definition. Asymmetric carbon, asymmetric carbon atom or chiral carbon, or chiral center, simply means a carbon which is attached to four different groups. A carbon which is attached to four different group. Okay. So except ketotriose, mean this compound, dihydroxyacetone, they don't have any asymmetric carbon atoms, and that is why they don't have any optical isomer. There is no optical isomer which can be seen in case of dihydroxyacetone. So except ketotriose, all aldoses and ketoses, they contain asymmetric carbon atoms and are optically active. So asymmetric carbon atom or chiral center is a carbon attached to four different groups. Any carbon which is attached to four different groups is supposed to be, when it is known as what? Chiral carbon or asymmetric carbon. Okay. So, very important note, write down that except ketotriose, that is dihydroxyacetone, all aldoses and ketoses are optically active. Are optically active. So except dihydroxyacetone, this compound is optically inactive. This is optically inactive, while all aldoses and ketoses, they are optically active. Now, the number of optical isomers depends upon the number of chiral carbon, depends upon the number of asymmetric carbon. Number of asymmetric carbon the compound is having. Okay. To find out the number of isomers, there is a formula which is 2 power n, where n is number of chiral carbon. Understood? Is it clear? Yeah. So in case of trioses, if you consider, so glyceraldehyde is having one asymmetric carbon, one chiral carbon, So number of isomers will be 2 power n, that is 2. Okay. For dihydroxyketone or dihydroxyacetone, no chiral carbon. Number of isomers will be, that is 0. Okay. Number of isomers will be 0. I'll write directly 0 because 2q over 0 becomes 1. 0. Clear? Now, in the further study of monosaccharides, we got aldotetroses having 4 carbon. Examples are erythrose and therose. Okay. Then ketotetroses, 4 carbon. Example is erythrulose, erythrulose. Okay. Understood? Yeah. Then aldopentose, 5 carbon. Examples are ribose, xylose, arabinose, ribulose. Okay. Ribulose is the ketopentose. So arabinose, ribose, xylose, okay, they they all are aldopentoses, 5 carbon. Even 2-deoxyribose also comes under this category. Ketopentoses having ketonic group of 5 carbon includes ribulose, okay, xylulose. Understood? Then, most important, aldohexoses, 6 carbon. We have glucose, mannose, allose, aldrose, and so on. Okay? And ketohexoses, 6 carbon. It includes fructose, sorbose, and tagalose, etc. Overall, there are 16 optically active forms. There are 16 optically active forms of aldohexoses, of aldohexoses. 16 optically active forms of aldohexoses. Okay. Each optically active form exists in two forms, okay? And these two forms are known as what? The enantiomers. Okay, they are known as what? Enantiomers. These enantiomers, they can be written as positive or negative, as you have already studied in the organic chemistry. Okay, each optically active compound shows positive or negative depending upon depending upon their tendency to change or rotate the plane of polarized light. To change the plane of polarized light. So each optically compound is showing the positive or the negative, that is dextro or levo, depending upon their tendency to change or rotate the plane of polarized light. Okay, we will be further studying about the relative configurations. Okay, then we will study about the optical configurations, okay, of the sugars, especially, which is very important to learn to understand the properties of sugar. First, I will be talking about the preparation of glucose, okay, which is very important, okay. So I will be talking about all these. I'll write here, okay. So right here, we will be talking about, we will consider enantiomers, okay, optical isomers, what is optical activity, okay. Then we will also consider anomers, epimers, mutarotation. These all things will be, we will be talking in detail in the coming lectures. But right now I am going to start with the very important, that is preparation and the properties. Okay, now glucose C6H12O6, it is a aldohexose. Okay, glucose is also known as dextrose, okay, because it occurs in nature as optically active dextrorotatory isomer. So glucose is also known as dextrose because in nature it is available as optically active dextrorotatory isomer. Clear? Okay. Glucose is also known as grape sugar, also known as grape sugar. So glucose is also known as grape sugar as it is found in most sweet fruits such as grapes, mangoes, apples and pears, etc. Okay. It is present in honey. Okay. It is also present in honey and is an essential constituent of human blood. It is known as grape sugar also present in honey. Okay. In humans, the normal or the optimum blood concentration of glucose is 65 to 110 milligram per deciliter of blood, which is known as what? Blood sugar level. Okay. Blood sugar level milligram per deciliter in 100 ml of blood. Okay. The level can change depending upon the type of condition or the disease person is suffering from. Okay. Now, the glucose combines to form disaccharides and polysaccharides in the form of starch and cellulose. Okay. It is also present in different types of glycosides like amycretin and celiacin. Okay. So, glucose serves to make different types of important biochemical products. Okay. So, we will be studying about the preparation part, that is laboratory method of preparation. Laboratory. It is prepared by acidic hydrolysis, acidic hydrolysis of cane sugar, of cane sugar, that is C12H22O11 in alcoholic solution. In alcoholic solution. Okay. So the acidic hydrolysis of cane sugar, that is sucrose in alcoholic solution, delivers two products which are the isomers to each other, that is glucose and fructose. So C12H22O11 acidic hydrolysis to form C6H12O6 plus C6H12O6. One is glucose, which is a aldohexose. One is fructose, which is a ketohexose. Keto sugar, aldose sugar. Okay. So sucrose undergoes acidic hydrolysis. Okay. Dilute HCl is used for hydrolysis. Used for hydrolysis. Dilute HCl is used for hydrolysis. Glucose is much less soluble in alcohol, okay, than fructose, and that is why alcoholic solution is used to separate out by crystallizing glucose, okay, on cooling. Okay. So I'll write here glucose is less soluble in alcohol. Glucose is less soluble in alcohol than fructose, than fructose. Okay, so fructose is more soluble in alcohol, okay, than glucose. Now, next slide. Yeah, here I'll write down. This becomes the principle to crystallize out the glucose. Okay, so glucose gets crystallized and can be separated. Because fructose is more soluble and glucose is less soluble. The one which is less soluble can be easily crystallized out of cooling. Okay, on cooling. Now, afterwards they are separated by filtration. Okay, then comes on industrial level. On industrial level, on industrial level, on large scale, the glucose is obtained by the hydrolysis of starch. By hydrolysis of starch. Okay, by the hydrolysis of starch. Corn starch or potato starch. Or potato starch. Hope you are getting it. Okay. Now, on boiling the starch with hot and concentrated, sorry, hot and dilute H2SO4 or hydrochloric acid, okay, at 393 Kelvin under 2 to 3 atm of pressure, okay. So on boiling with hot and dilute, very important, okay, because for hydrolysis we can use dilute acid only. If you are using concentrated acid, then the sugar will undergo charring. Okay, so that charring process of sugar will ultimately lead to formation of black charcoal. Okay, so on boiling with hot and dilute H2SO4 or HCl at 393 Kelvin under 2 to 3 atm pressure. Okay, so C6H10O5 whole N. This is starch, NH2. It will undergo polymerization to form. Okay. So glucose undergo polymerization to form starch. Okay. Starch undergoes depolymerization, fragmentation, degradation to form glucose. Okay. Understood? So starch is boiled with dilute acid till the hydrolysis is complete. Okay. The excess of acid is neutralized by chalk or calcium carbonate. Excess acid is neutralized by calcium carbonate. Okay, the glucose obtained, okay, in the filtrate which is having glucose is further decolorized with animal charcoal. It undergoes decolorization with animal charcoal. Okay, now physical properties of glucose. Physical properties. Physical properties of glucose: colorless, crystalline, solid. Melting point 146 degrees Celsius. Okay. Highly soluble in water. highly soluble in water. Okay, it forms aqueous solution on on dissolving with water, and it separates out as a crystalline monohydrate which melts at 86 degree Celsius. So it is highly soluble in water, and thereby it makes an aqueous solution in water. Okay, and it can be separated from its aqueous solution as a crystalline monohydrate which melts at 86 degrees Celsius. Okay, it is sparingly soluble in alcohol. It is sparingly soluble in alcohol. Okay, and insoluble in ether. So it is sparingly soluble in alcohol and insoluble in ether. From its aqueous solution, from the aqueous solution of glucose, it can be crystallized. It can be crystallized as monohydrate. Okay, which is having a melting point of 86 degree Celsius. Okay, it is less sweet, I mean 3-4 times in comparison to cane sugar. Time in comparison to cane sugar. In comparison to cane sugar. Okay, it is optically active and occurs naturally. Okay, the natural occurring form of glucose is dextro. Okay, and it also shows mutar rotation. Very important. We will be talking to this term once we will complete the the properties, especially the preparation properties, chemical properties of glucose. Okay, mutar rotation. It also shows mutar rotation. Okay, the optically active natural form of glucose is dextrose. Okay, optically active natural form is dextrose. Okay, understood? Now coming to next, chemical properties. Glucose is a polyhydroxyaldehyde. Okay, as you know, aldohexose. It has 5 OH groups. Means 5 OH groups, as it is a pentahydroxy. Okay, there are out of 5 OH groups, there are 4 OH groups, alcoholic groups, which are secondary alcohols. Okay, 4 OH groups means the alcoholic groups are secondary alcohols, and one alcoholic group is primary alcohol. It is primary alcohol. Okay, there is it is having one aldehydic group, one aldehydic group. So they show chemical properties of alcohols as well as aldehydes. It will show the properties of alcohols as well as aldehyde. Okay. Now, glucose showing the properties due to OH group, presence of OH group in glucose. First is the formation of pentaacetate, okay, which is a kind of esterification reaction. The reaction takes place with acid chloride or acid anhydride. As you know, that alcohols on reacting with acid chloride or acid anhydride in the presence of base or the acid, okay, they form esters, okay. So in this reaction as well, glucose it penta forms penta acetyl derivatives, okay. It forms penta-acetyl derivatives with acid chloride or acid anhydride in the presence of anhydrous zinc chloride, anhydrous zinc chloride, okay, ZnCl. I'll show you the reaction. This is CHO, okay. So you can see secondary, primary. This is secondary alcohol. This is primary alcohol. It undergoes the reaction with 5 moles of acid chloride or acyl chloride, acetyl chloride, okay. Okay, the reaction is basically conducted in the presence of ZnCl2, or we can take a mild base like pyridine to maintain the pH of the reaction, okay. So now you can see that the 5 OH groups, they will undergo the addition of acetyl group, okay. So you can see that I have added CH3COO, this group. So this is glucose pentaacetate, pentaacetate, which is a mixture of, here I have taken a mixture of alpha and beta. Okay. This reaction confirms that glucose is having 5 OH group. Confirms that glucose is having 5 OH groups. Clear? Now, the next reaction is reaction with PCl5, as we have already learned in the preparation of haloalkanes, okay, that alcohols they undergo reaction with PCl5, okay. So reaction with PCl5 will deliver basically pentachloroglucose. So glucose reacts with phosphorus pentachloride PCl5. Okay. See. Okay. The byproduct will be phosphorus oxychloride pentachloroglucose. Then the next reaction is reaction with metallic hydroxides. Glucose, it act as a weak acid. Okay, glucose behave as a weak acid. Okay, it reacts with certain metallic hydroxides like calcium hydroxide, barium hydroxide, strontium hydroxide, like that. Okay, to form salts, to form salts. These salts are known as what? Glucosides. Okay. Next reaction is formation of glycoside. That's important. That's very important. Formation of glycosides. Glucose, when treated with methyl alcohol, reaction with methyl alcohol. Okay. In presence of dry HCl gas. So reaction with methyl alcohol in the presence of dry HCl gas. Okay. Glucose forms monomethyl ether. Glucose forms monomethyl ether. Glucose forms monomethyl ether, which is actually, we can say, which is actually a mixture of alpha and beta forms. Okay, glucose forms monomethyl ether, which is a mixture of alpha and beta forms of glucose forms. It indicates that these alpha forms and beta forms, they have one of the OH group which is different from the other. Okay, so formation of glycosides basically confirms it supports the glucose. It is having a cyclic structure. The reaction confirms that glucose show cyclic structure. Okay, now see C6H12O6. Okay, this is glucose. I will write this glucose in this way: C6H11, H11O5OH. This one of the OH group plus methyl alcohol. Okay, it undergoes a condensation reaction. Okay, in the presence of HCl. Okay, it forms C6H11O5 OCH3. This is alpha and beta methyl monoether, which is known as what? Methyl glucoside. Okay, plus H2. Now, when you will look as the structure point of view, when you will look at the structure point of view, it will look like this: carbon, so previously I was writing CHOH whole 4. Okay, but right now I'm writing that CHOH whole 3 and then CH. Okay, so in between this carbon and this carbon, they have this linkage. Okay, so this carbon which is having a ethyl linkage with this carbon, the fifth carbon, okay, which is basically a glycoside form, alpha D methyl glycoside. It gives a confirmation that okay, the hydroxyl group of the fifth carbon of the glucose undergoes basically a nucleophilic addition reaction on the carbonyl carbon to form hemiacetal. Okay, alpha D methyl glycoside. The melting point is 483 Kelvin. Okay, and the specific rotation, it's come to be 158 degrees. Okay, of this variant. So this is alpha form. Now the beta form, you can see the anomeric carbon. This is the anomeric carbon. I will make a star. Okay. This is beta glycosidic form. Okay. beta dimethyl glycoside. Its melting point is 380 Kelvin, and specific rotation is minus 33 degrees. Okay, here the specific rotation is 158 degrees. So now the reactions of carbonyl groups. Reactions of carbonyl group means the aldehyde group in glucose. Okay, the first is reduction. As you know, aldehydes, they get reduced to form the aldehyde group. It get reduced to form alcohol. Okay, the first is reduction. So in the presence of sodium amalgam alloy NaHG, okay, in aqueous solution, or sodium borohydride NaBH4, okay, the glucose is converted into sorbitol. Okay, so glucose to form sorbitol. Okay, you can see CH2OH, CHOH, whole 4, CHO. Reduction means addition of hydrogen to the sodium amalgam alloy, water. Okay, the effect is on CHO group, that is the carbonyl group. Okay, not at the hydroxyl carbon. D orbital. The reason is that both sodium borohydride and you can say the sodium amalgam, they can reduce the carbon double bond oxygen because carbon double bond oxygen is having more reactivity, but they cannot reduce the hydroxyl group, okay, to alkenes. For that we can use HI, okay, in the presence of heat. So on prolonged heating in the presence of HI, on prolonged heating, okay, the reduction happens, okay, it can be converted into N-hexane, can be converted into N-hexane, okay. Previously there is a formation of an compound 2-iodohexane, then it forms N-hexane. So on prolonged heating with concentrated HI and red phosphorus at 110 degrees Celsius, red phosphorus on 110 degree Celsius, glucose forms a mixture of 2-iodohexane and N-hexane. Mixture of 2-iodohexane and N-hexane. Okay. Now comes the oxidation. Okay. In oxidation reaction, we got to know about most importantly, okay, that glucose undergoes oxidation with different types of oxidizing agents. Okay. So the oxidation reactions of glucose I will be starting in the next one, my dear students. Okay, which includes the reaction with Fehling solution, Tollens reagent, bromine water, nitric acid. Okay, reaction with HCN and many more. So oxidation reactions of glucose I will be taking in the next turn. Till then, bye bye. Take care. Stay safe. Stay healthy.